All right, now let's move on to lesson 9.4, page 378, where we're going to continue with surface areas and volume, but now we're moving. We're moving from the first three lessons being surface area, now we're going to volume. And we're going to use the formula to find the volume, and we're going back to our original figure, the prism. So we're going to find volume of a prism. So we got to know what volume is. Ladies and gentlemen, how can you find the volume of a prism? That is our essential question. How do you find the volume? Well, first of all, you took some notes on volume of a prism. From the key idea at the top of page 378, you read, you kind of have an idea what's going on. And remember, volume. Volume of any figure is what? Think about it. What is it? Volume is the amount of space that what? That the figure can hold, or the amount of space that the figure occupies, so to speak. It's measured in cubic units. And the reason it's measured in cubic units is because you're measuring the unit times the unit times the unit. And when unit times unit times unit, you add the exponents, that's 1 plus 1 plus 1, you get cubic units for volume. All right, so here we have two prisms. We have the rectangular prism and we have the triangular prism. And I really don't appreciate that they don't highlight these bases like they should. So the opposite, parallel, congruent sides, because that's important. We always have to highlight the bases. We know there's two of them. And the deal with this is we still deal with area of the base and we still deal with height. However, to find the volume, we are simply finding the area of the base and multiplying it by the height of the prism. So in other words, the formula looks something like this. Volume equals capital BH, where capital B, once again, is area of the base, and H is the height of the prism. I'm glad they used this one because that is the appropriate one. It matches what we were doing before. It has some of the same stuff in it, like capital B for the area of the base, and then H, the height, which is the distance between the bases. It's always the distance between the bases. So we just have about 6 or so examples to get through, and we're going to get through these pretty dang darn quickly. So let's find the volume of this rectangular prism. So volume is equal to area of the base times the height. And we can recognize by highlighting a base, I'm going to highlight the bottom one. Most people are comfortable with the bottom and the top. I could highlight the two sides, or I could highlight the front and the back on a rectangular prism, and I could make any one of those the base. And so the base is a rectangle of some sort, and that's base times height. So on our particular one that we highlighted, that's 3 times 2. And we're multiplying that by the height of the prism, the distance between the bases, that is 4. 3 times 2 is 6. 6 times 4 is 24. And the units are centimeters, and we're now finding volume. That's centimeter times centimeter times centimeter. They all have an exponent of 1. We don't see it. So 1 plus 1 plus 1, centimeters cubed. Moving right along to our example number 2, where we have another rectangular prism. Volume is equal to area of the base times the height. Volume is equal to area of the base times the height. And so our base, once again, I'm going to use the bottom. Most people are comfortable with the bottom, so I'm just going to stick with it. And that's base times height. Those numbers are 4 and 5. So 4 times 5 for the base, the area of the base, times the height of this prism, which is 3. The distance between the bases. 4 times 5 is 20. 20 times 3 is 60. Our units are inches. We're finding volume. They're cubed. I'll tell you, volume is an easy, straightforward idea. Our next example, we have another rectangular prism, and we're going to find volume, which is area of the base times the height. Our base, once again, you know what, just because, I'm going to use the side, just because. I'm going to see what happens. I'm going to use the side. I'm not going to do it both ways, but I'm just going to use the side. You guys can find it out if you want to use the bottom one. But I'm going to use the side, and that's still base times height, because those are two opposite, parallel, congruent sides. They're both rectangles, base times height. That would be 2.5 times 1. And then the height, the distance between the two sides that I'm calling the bases, is 9. And 2.5 times 1, well, that's 2.5. And that times 9 is 22, 22.5. And our units are centimeters. We are finding volume, so it's cubed. Let's try now with a triangular prism. Find the volume of a triangular prism. Guess what formula we're going to use? Absolutely right. The same dang darn one. But now we find when we look at this prism, we see that our base is a triangle. So we got base times height divided by 2 for that triangle. And so in this particular case, we're looking at the triangle. We have 12 and 4, or excuse me, 10 and 12 as being the base and the height. And then we're multiplying that by, we're multiplying that by the distance between the two, which is 16. And when you multiply 10 times 2, whoops, we forgot something there. We got to divide it by 2. Don't forget that. We got to divide by 2. So 10 times 12 is 120. 100 divided by 2 is 60. And 60 times 16. 60 times 16 does give us 960. And we've got meters, and those meters are cubed because we're talking volume. So I almost made a classic blunder error. I almost forgot to divide by that 2. You got to make sure you keep that in there, dividing by 2. Going on to our next one. Again, volume is equal to area of the base times the height. And we've got our base right here. It is a triangle. We got another one in the back. All right? And so it's base times height divided by 2. One of the reasons why I write that out underneath my formula, because I almost forgot it even though I did write it. But if I didn't write it, I certainly would have forgotten it. So now I'm going at the base and the height. That's 5 times 12, dividing that by 2. And multiplying that by, I'm doing that every time. Multiplying that by the height, the distance between the two triangles is 3. So 5 times 12 is 60, divided by 2 is 30. 30 times 3 is 90. Wait a minute. Yep, 90. Because that's 6. 5 times 6 is 30. 30 times 3 is 90 inches cubed for the volume of that triangular prism. All right? Uh-oh. I made a mistake. Made a mistake. I thought I was doing something wrong, and I just went back and looked. I had the wrong units, didn't I? Volume equals area of the base times the height. And the base times the height divided by 2, the numbers are 2 and 5 divided by 2 times the height of 3. So that's 10 divided by 2, which is 5. 5 times 3, that's 15 inches cubed. Woo! Someone was ready to come to class tomorrow and say, Mr. Ross, you got it wrong. Woo! I saved myself. Nice. But I know you guys caught it. You guys caught it, and you could tell in my voice. For some reason, I didn't think something was right. But let's move right along to our last example before our first quick write tonight. Find the volume of this triangular prism, where volume is equal to area of the base times the height. And we know that that base is a triangle. Base times height divided by 2. We highlight that so that we can find the base and height of that triangle. And when we copy it down correctly, that's 6 times 1.2. And we're dividing that by 2. 6 times 1.2 divided by 2. Okay? And we're going to multiply that by the height. And the height is the distance between, which is 3. And 6 times 1.2 divided by 2 times 3 gives us a volume of 10.3. And the units are yards. We're finding volume. It's cubed. We're done with our first video. Let's get our quick write done. Find the volume of each prism. So you have 2 of them tonight on the first quick write. And you might want to just draw a quick little figure. And you have 11, 2, and 3 for the units on the rectangular prism. You have 5 and 3 for the base and height of the triangular prism, and a length of 12. Go ahead and get that done. Again, take a snack, take a drink, talk to your mama. Tell her what you're learning. I'm sure they're curious. They want to remember. They want to revisit their junior high years. And then I'll see you back here in just a few minutes for video number